Okay, class, tonight we're going to be doing exponential transformations. Now, looking at the sheet, we know that the following exponential equations are always in the form a times b to the x power. So I want you to complete the chart to describe how differing values of a and b will affect the graph of these functions. So now we want to know how does it transform, which is determined by how it moves. So on the first one here, I know that y1 equals 2 to the x power. So what is my a in that? Okay, it's telling me that it's 1, which would make my b, 2. And then they graph that over here. Now what happens now if I make my a 3? Is my a 3 here, or is my b 3 here? Okay, this should be a 1 and a 3. On y3, that would make it a what? A 1 and an 8. Because we know that we can write these separately. So how do those graphs compare to each other? How did they move? What is something that they all have in common? If you said y-intercept, that's correct. They all are crossing at this point right here. So everybody see that? Right there. They're all crossing. But what do you notice? As b gets bigger, the graph gets steeper. And our word for that is what? What do we use for the word steeper? That's correct. Horizontal compression. So this is an example of what you need to write right here. So remember, if you need to pause your video and write that, you can do so now. So now let's look at the next one. Okay, on the set problem number 2, what do you notice about the 0.6? That's going to be my what? I know anything by 1 is going to give me that number, so that's going to make b my 0.6, and that's going to make a my 1. So what values would we have for the second one? What would my b be? That's correct, 0.4, which is making my a 1. And then the last one, I'm going to have 0.1, making my a 1. So again, I notice what about these graphs? They have the same y-intercept, which is 0, 1 in this case. And what do you notice about the steepness of it? They get steeper. It's a horizontal compression. Okay, now I want you to take a moment and I want you to work set 3 and set 4 by yourself. Just go ahead and pause the video for a minute and see what happens. Okay, guys, on set 3 and 4, I just wanted you to get a general understanding on what happens. Any questions you have for that, we're going to go over tomorrow. I'm going to go ahead and go to the next page, but just pay close attention on set 4 to y3. What did that negative do to it? Make sure you have that answer for me tomorrow. Okay, now let's take a look at the next page. So what I'm going to do here is I'm going to summarize the findings. You're going to put a big asterisk by this page because these are your specific notes. This is what you always need to know. You're going to have to know how your A and your B and your X moves everything. So make sure you understand these. So what do we notice when our A is greater than 1? Something that we've talked about before. When your A is greater than 1, you have a vertical stretch. What about when your A is in between 0 and 1? You have a vertical compression. And when your A is less than 0, which means it's negative, what does it do? It reflects over the x-axis. Now, if my B is greater than 1, then my graph is going to increase from left to right. And if it's in between 0 and 1, it's going to decrease from left to right. And don't worry, we're going to work plenty of these problems so you can really understand what that means. So now we're going to look at my k here. So I see that it's really going to be plus k because that's my value that sits off to itself. So what's going to happen if my k is greater than 0? What if we learned that k controls up and down movement, correct? So if my k is greater than 0, it's going to translate up. If it's less than 0, it's going to translate down. And if y equals k, then that becomes my horizontal asymptote. So we're going to use those values at the top to figure out the bottom. So what do I know about my graph from the bottom? I know A is what? A is going to have to be less than 0 or greater than 0 in this case. And what is B going to have to be? Because of the way it looks, B is going to have to be greater than 1. And what do I notice about K here? K is going to equal 0. Okay, let's look at the second graph. Because of how this looks different from the other one, I know that my A is going to have to be greater than 0. My B is going to have to be greater than 1. And my K is going to have to be less than 0, greater than 0, or equal to 0. Now in the last one we notice that my A is going to have to be greater than 0. My B is going to have to be less than 1. And my K, because the position is going to have to be less than 0. So I want you to look at your last page and see if you can figure out what would happen if your B became 0 in this instance. But only look at the top half. We're going to work on this, but I want you to take a look at it to see what you can figure out on your own. Okay, I hope you took good notes, and I'll see you in class tomorrow.